Hi, my name is Christina, and I'm here to talk to you all about borrowing the best of web to make Android better. How many of you were at the Square Talk? I know at least one. Anybody else? Oh, wow, a ton of new faces and a ton of old ones. This is great. So today I'm going to go into more detail than I did at the Square Talk, but for all of you who weren't there to hear the first version of this, I'm also going to cover that part as well, the basics, and why I think this is really going to help us out on mobile. So with that, let's get started. So what is the state of mobile right now? Well, basically we're developers and that's great, and so everybody thinks we can do everything. And I mean, granted, we're pretty cool, so we can do most things, but I mean, we are asked to do a lot. Some of those things we have to optimistically fetch, we have to do route transitions, and they require different things. We're talking to the server at all times, we have caches, we're doing a lot of different I/O processes, and we're mutating a lot of things, and all of that, it can get pretty sticky because we have to do a lot of things and we have to do them at the same time, and we're juggling all of these different balls and trying not to let anything drop. And so it is of course possible to do, but it's not easy, and I think that this is what introduces a lot of errors into our work, is the fact that we're asked to do it. Like for a simple friend button, this is the example that I'm going to return to later in the presentation, which is why I bring it up now. But just for a friend button, we have all of these different things. We have a local status, you know, are they friends right now, currently, that we can tell on the device, but then maybe someone out there somewhere has friended them, so now the server has a new state for us, and we need to figure out what that is. And then if they tap it, even if the server's not back, we want to update it, but now we get into this state where we have, you know, a newly updated local state, but then the server is going to come back and now we have to merge them together, and that's nightmare scream face there. And then, I mean, also that you're not even touching on the transitions that we have to do. So, okay, well, they're friends, so when you transition to their profile, you better show them all the things that a friend would see, or if they're not friends, well, you better be fetching all of those blocked state profiles because they're not supposed to see anything. So all of this is for this thing. This is one of those moments where you work for like 20 hours on something and you go and you show your mom or your boss and you're like, look at how cool this is. And they're like, that's all you did today? Well, yeah, it's pretty hard. Like, it's hard stuff. So, you know, like this button transition, it's not easy. And my favorite quote that covers exactly why I think it's not easy is this one from the founder of Redux, the guy who wrote the library. And it points out the fact that mutating things and calling things asynchronously, those are both great in and of themselves. Like, they're really good, they let us do all of these things that we want to do, but as soon as you start melding them together, things can go wrong because they're really hard to reason about. It's not counting where you can look at your fingers and go 1, 2, 3, 4. They're things that you really have to put a lot of brain power into, and you can sometimes make it, you know, wrong. And so he compares them to Mentos and Coke. And okay, I know we have a lot of coders in the room, and so maybe science wasn't your strong suit and you were coding instead of doing the labs. Well, here's a reminder of what that looks like. To borrow a phrase from my boss, it's a trash fire. It's a pretty trash fire, but it's a trash fire. It gets bad real quick. So luckily, we are not the only people with this problem. Misery loves company and all of that. We have web allies, and people on the web, they've been dealing with these problems for longer than we have. They were around before we were, and they iterate a lot faster, mainly because they have a lot more resources. Everybody is throwing resources at the web in a way that mobile hasn't quite caught up to yet. So what have they come up with? Well, I'll let you know, spoiler alert. Here are the ones that I want to point to. The image is up on screen. Redux, unfortunately, does not have a logo, so shout out to Redux, please get one. But then there's also Cycle.js, there's Flux, and then there's React Native. Does anybody here use React Native? Okay, so more familiarity with that than maybe some of the other ones up on screen. I'm going to take a moment to dive into each of these technologies because when I show the example, particularly CycleJS and Redux are going to come heavily into play. So let's go through some of these. You can really take two approaches to managing your app. You can look at views and you can look at the state. React very heavily leans on the views. It is a view library, but there are ways to manage state without also managing your views, which is what Redux and CycleJS do. So to look into React Native, React is, like I said, a Vue library, and it functions on the premise that data should be passed down. And you can have these special tags so you can splay properties through them, and it's reactive programming. So what does that look like in code? Well, you have this thing, it's called view props, and maybe you have a way to identify which screen you're on. It's stringly typed, which is terrible, but bear with me. You have feed props in there, you have profile props in there, and then when you render, you can do something like this. Am I on the feed screen? Okay, let me splay out these props and pass them down to the feed tag. And if I'm on the profile, I'll splay those props, and now those things can have props inside them, and we can keep this going until at the bottom level render, you're doing things like setting strings or formatting strings or numbers. Redux, on the other hand, it looks at the state of your app. They're usually used together, but Redux itself does not need to be used with a view-based management system. It consists of actions and reducers, and so you have actions that are emitted, and they go through a reducer, and that reducer tells those actions how they should mutate the store. So fundamentally, what you're doing is you're emitting state and you're reacting to the actions that mutate the state. Now, disclaimer here, when I was writing these slides, I was thinking, oh wow, originality, it's so great, I should make all my own original examples. And then I had this light bulb moment where I realized that there's no way in 30 minutes I can make a better example than the guy who wrote this paradigm. So I'm gonna go ahead and use the one straight from Redux because I think that they probably put a lot of thought into them and they're very clear, at least to me. So going forward, all credit goes to Dan. I don't wanna take any of it, it's not me. Now, it might be hard to see this, but the great thing about it is that you really don't need to be reading this code to understand the three blocks that are going on here. The first is that you have some state currently. In this example, we're using a to-do list, and so this state describes the to-do list at this point in time. That's all it's doing. That's the previous state. In the middle, we have an action. In this case, the action is to add a to-do. It could be anything else. It could be remove one. It could be to mark it red. Any action that a to-do list can take, you can describe here. And that very last line, it's the key to Redux. What's going on there is that you're passing your action and your previous state into a reducer. And so that reducer is then spitting out the next state by mutating the old one based on this action. So in this case, the next state is going to have a new to-do, and it's going to say, understand the flow. And then hopefully, once you finish this Redux example, you would be able to cross that off. Now, like I said before, Redux and React are often used together. They don't need to be, but they often are. And so when you combine them, you get a structure that looks a little something like this table. And that is to say that your components can kind of break themselves up very logically into presentation components and container components. And unsurprisingly to most, presentation components tend to be stateless. They don't need to be, but they tend to be. And container components tend to have a lot of state. They are the data source. They are telling the presentation components how to render themselves. Presentation components have no idea what Redux is. They don't need to. They get all of their information from props, whereas the container components, they actually do know about Redux, and they are generating the data that the presentation components use to render themselves. So this is how those kind of mesh. Now, it's worth looking at CycleJS as well, and it has a very similar ideology, but you'll notice that nowhere in here is there a store and nowhere in here is state. So what CycleJS is doing is it has a bunch of sources, and they go through pure functions. And pure functions, that definition, in case people haven't come across it recently, it means that it's a function where if you put an input in, you are guaranteed to get the same output for that input. Now, obviously, if you're making any web request, that is not a pure function because that can 200, it can 400, it can do any number of things. So the same input does not guarantee the same output, and it's not pure. We call things like that side effects. And in CycleJS, side effects are handled by drivers in the external world. So here we have a source, we go through pure data flow, and then we have a sink, which is where you output your data and have something render it. This is exactly what I just said, and the key point here is that there is no state. Anybody who knows JavaScript or any sort of React library is probably familiar with this .set state. We have none of that. Also key to note that CycleJS is created using RxJS, which is great because some light bulbs should be going off that we have RxJava, and if you can make it in RxJS, then you can also make it in Java, and oh wait, this is great, mobile development. So, spoiler alert, this is where we're heading. Now, again, the code here is really not as important as the diagram is. What's happening in this simple counter app that's on screen right now is that we have sources and we're splitting them out. So we have a decrement source and we have an increment source. And these are being combined into an action source. So you can see that decrement, it will emit a series of -1 numbers, while increment will emit a series of +1 numbers. So when we combine those into the action, we now have a stream of observables that consists of +1s and -1s. The next step, count, we're doing a scan, which is basically just adding those as they come in. So you can +1 and then go up to 2 and then go back to 1 and then et cetera, as those negatives and pluses roll in. Now at that point, this is a counter app, that's all you need to have. So you take that count and you output it to your view and we're done. You can see that this is unidirectional. All the data flow is going in exactly the same direction and there's nothing heading back upstream. Now, I'm going to make a shout out to Flux just because Facebook is fond of it, and you might come across this as well. It won't come into play in our example later, but you can see here that it's much of the same. It has a dispatcher, it has actions and a view and a store. So your view, it will emit actions. The dispatcher will route those actions to the appropriate store because in Flux you can have more than one, so you need to know where it should be going. And then at that point, the store will emit something that's mutated that the view will render. So shout out to Flux. Now, hopefully the graphs have made this clear, but the thing that all of these have in common is that their data flow is one direction and it's circular. So you never see arrows going back up the screen or going back to the left. They're always in the same direction. And why does this work for us? Well, it separates concerns. There's a time and a place for everything. And so when you're doing your mutations and when you're doing your asynchronous calls, they are always happening at the same point in time and you are never mixing those concerns. So you can eliminate a lot of bugs that way. Now, what does this buy you? Well, it buys you a lot. And primarily it buys you something when you're writing the code in that it's easier to get correct the first time, but it also gives you a lot of gains when you're debugging the code because it's easier to reason about your app and what's happening at any point in time. So the logic is made easy. I think you're all going to see this really clearly when I go through the example. But with this sort of paradigm, your logic becomes, oh, I have a to-do. What should my state be? I should add this single string here to my to-do list. That's pretty easy to do, and I have faith that all of you can do. You're not trying to merge a bunch of network requests and then check the cache at the same time and then queue up a segue to go somewhere else. You're doing this one thing at a time, so the logic is very easy, and thus it's very easy to get right. A sub-point of this is that because your data flow is explicit instead of implicit, you always know at any given time what's going on, and it's easy to know what you need more of, what you need less of. Also, edge cases, because of this, it's very easy to see. I can't tell you how many times we've corrected products since we've adopted this paradigm because there was this one thing that they didn't think about, and when you're coding it, you have to cover all the edge cases. So we're finding these edge cases in development as opposed to in production, which I think is a win-win for everybody. Now, as far as debugging goes, depending on the technology that you're using, you can do a lot of really cool things. You'll notice that several of them have data stores, not CycleJS, but the rest. And what that means is that at any given point in time, your entire app state is in an object. And that's great because objects can be stored and objects can be printed and objects can be loaded into memory. And so if you crashed and you've recorded the series of objects that led you up to that state, you can do things like time travel and rewind through those objects and then step through each state that led up to the crash, see which action was emitted to make it crash, and then fix it. You're not guessing where this came from. You know exactly where it came from because there was a state, there was an action, and after you combine them, your app crashed. So time travel is very useful. It's useful in a lot of other ways, but I think that's probably the most revolutionary in terms of debugging for us. The immutable objects point is also really key. These paradigms make it really easy to get rid of mutation altogether because they're emitting new state objects. Even when you're doing things in JavaScript where things can be mutating, you're always emitting new objects, so you're not mutating them. And I think it's probably not controversial to say that mutation adds a lot of bugs, and so always having immutable objects makes it easier to follow logic flow, and it eliminates those bugs. So how can we bring this stuff to Android? How can we benefit from what the web is doing? Well, there's two ways. We can use React Native, which is already out there, and Facebook is, sponsoring it, or we can do something natively to re-implement these ideas. The pros of React Native, I'm sure most of you are familiar with, but there's a large development community. It's maintained by Facebook, which means that progress is always ongoing, bug fixes and new features and the like. You have this quasi-cross-platform ability, which is to say that because you're writing in JavaScript, in theory, you can route it to both your iOS and your Android client. In practice, because those at a lower level have different components, you do need to tweak the code, but much less so than obviously writing two very distinct clients. And then you can do fun things like code push, which is not so relevant for us because the Play Store is great and lets us propagate apps out in only a couple hours. But for people on iOS who are stuck between a 2-week waiting window, if you want to do live code push, you can just send out your new JavaScript and people have it instantly, and there's no going through approval anymore, and that's awesome. Now, there are some cons, which is to say that when I'm using React Native, I spend a lot of time debugging methods that maybe haven't been implemented yet, or maybe haven't been fully vetted for various kind of obscure bugs. There's upfront integration costs in that you are trying to take your native app and bring in web technologies, and those need to mesh somehow, and it's not always easy, as you can imagine. Now, the biggest thing for me, I think, is this third bullet point here, which is to say, we develop in Kotlin. Kotlin is fantastic, I highly recommend it, and you're asking me to give up Kotlin to go to JavaScript, and I mean, JavaScript is great, but no types, which is not so great. And so it's really hard to give up a strongly typed language that will really help you as a developer and go to one that will not catch your errors and will rely on you to debug things that otherwise would have been caught. There's some perf hits, and it's not totally well documented, but I think that those are also both things that you can get around. Now, native reimplementation, spoiler alert, this is what the example is going to be, so I bias myself towards this, but it can be done in several ways. You can focus on the view, or you can focus on the state, and it can be done to several degrees in that the example that you're going to see shortly, it tiptoes in. We took problems that we saw and we replaced those specific areas of our code, but you can also do this idea where from the ground up your entire app is reactive. It's all based on a CycleJS principle. You can replace all of your layouts with layouts that are pushed according to the same ideas. But we're not, I mean, it's totally personal choice. We're not going to walk through that today. I think it's a bigger issue, but it is out there and it is something that you can decide for yourself. Now, the pros of re-implementing something is that you may be on the code, you may be using open source, in which case you can fork it, but you have a generally better appreciation for the code and you have more hands-on time with it, so you're not relying on someone else to not mess things up, which is great. The strongly typed language goes without saying, and of course, because this is in your own app, you have less ramp-up time because you're not trying to recreate something that you have no experience with. You're not trying to take an Android dev and make them into a web dev overnight. Now, the cons is that you also may be on the code. I know that's a pro, but at the same time, like, who's got time to fix all these bugs? Well, you're going to have to find it. So if you own the code, you have the cost of owning the code, and that can be a con as well. Bugs don't magically get fixed overnight in our code while I sleep, whereas with React, I'll wake up in the morning and they'll have a new update, and it's great. So you also have the possible upfront cost of actually writing this stuff. I think it's pretty minimal, but it's not to be ignored. And then, of course, not as much community support because, well, you wrote it. So our choice, I've already ruined the surprise here, but guess what? We went with the native reimplementation. Why? Well, we already used Kotlin, we use RxJava, so there was very little leap in going into this paradigm because they're built on it. We didn't have to learn new languages. We didn't have to learn about observables. We already had that knowledge. So it was a very seamless transition. It was really quick because of that seamlessness, and we got our first component into production in a week, which I think would probably not happen with React integration. There's so much testing to be done. And also, it was easier for us because we were doing it in our own app to start small and grow as we got more comfortable. And when we tried React Native, because we had to do all the integration, it kind of felt like you don't want to do all of that work for a very, very small button. So the fact that we weren't doing much work enabled us to do it for small things and grow from there. How? Well, I'm going to show you. And aside, how many people here use RxJava? Okay, so okay, good. I'm going to fly through this. I wasn't sure what the knowledge level would be. So RxJava, for the few people who didn't raise their hand, it's reactive programming with async data. The great thing about it is that it adds maps and filters and all sorts of subjects and other things for handling this data, but it really is just accessories to async calls. Well, they could be synchronous as well. What can it look like? You can have streams of clicks, you can have network responses, basically anything can be turned into a stream of data. You have it on next, you have it on error, and you have it on complete, and that's more or less it. So this is an example of what that looks like. You're emitting 3 things, you're mapping each one of those to 10 times its value. So now instead of emitting 1, 2, 3, you emit 10, 20, 30. Hooray, observables are great. The second thing that you're going to see in my code is a merge, and that is it takes 2 streams and it puts them into one. So you can see that their time is held constant here. So you have the 20, 40, 60 on that first observable, and you have the 1 now interleaved with the 60 and 80. So they are merged in time, and they're emitting on 1 observable instead of 2. All right, back to the main program. So where were we? We were going to see how this was done. Here we go. I'm returning to the friend example. Why? Because it seems easy, but it's not. I mean, these are the 4 states. I'm not even covering all the rest of them, and you can see several things about these states. Sometimes there's an image, sometimes there's not. Sometimes it's a full circle, sometimes it's an outline. Sometimes the text is green, sometimes it's white, sometimes the background's gray, sometimes it's not. Sometimes there's a count, sometimes there's an indicator, which is not on screen. But that 90 friends is usually badged if there are new friend requests. So within this single button here, there's so many things going on, and it was really difficult to get right the first time. And I think we spent probably 2 months before all the bugs were ironed out of this the first time. The second time, as I've already told you, we got it into production in a week, and it worked. So let's look at the file structure here. For each component, in the way we do this, and I'm not saying the way we do this is right, but in the way that I'm going to show you, each component has 4 different files. We have the component itself, we have a model, we have view intentions, and we have the view model. So I'm going to walk through each one of these and show how they relate to each other. We're going to start with view intentions. Now, view intentions, as we've defined them in our app, they describe all the things that can change this view. So you'll see in here there's a number of friends, which obviously will get rendered as the 90 friends you saw in that first button. There are clicks. If somebody clicks on it, we should do something about that. We have silent notifs that can update things in case someone friend requests you and we want to let the client know. And other ways to mutate this view. So what we're doing in view intentions is we're saying these are all of the things that can change this button and all of the things that we want to look at. This is very similar to the sources in CycleJS that you saw. Okay, now we're going to dive into the model. This is it. Like, this is the thing, guys. This is the model. So take a deep breath. All right? All right, ready? Great. Here it is. This is it. You can see here the most important part of this slide that I'm going to call out, I'll come back, don't worry, is that top line. And the top line, the type signature for this function, we are given view intentions. We're given all of the things that could possibly change this view. And what we emit is an observable that takes a state and maps it to the new state. Now this should seem really familiar. It should seem a lot like reducers. So we're taking a state, we're giving you a new state, and this is an observable format. So I just mentioned state. What does our state look like? Well, for this, let's say that there's a follow state, like are you friends or are you not? Is this your own account? And there's a number of friends. How many people are you friends with on the app? And this is going to be stored in RAM, so our state has just a single RAM instance with these. We can do fun things like initialize state with 0 friends into your own self account. Seems reasonable enough. You can do whatever you want, but this is how you would use that state object. Okay, back to the model. So what you can see by looking down this list is that we've split out all of those view intentions, and for each one, we're mapping it to that observable that mutates the state. So we have follow change from clicks, and follow change from dialog, and follow change from server, and all these other things. And in that very last one, we have the number of friends, because that only changes from one place, so we only need one of these. And that very last line there, we're merging them all together using that merge observable function, and so they're all being emitted in a single observable. And remember, what's being emitted is functions that change state. They're not state objects, they're functions that change state. So all of the things coming down this pipeline, they're mutating functions, and you can have a state object and just apply these functions to them and always have the correct state in your app. Okay, like I said, these should sound really familiar. The light bulb should be going off because this is essentially what a reducer is. Now let's look inside of one of these. This is num_friends. It's probably the easiest of these. And what it's doing is we have the intention, a new number of friends was issued, and so we say, okay, we have a new number of friends. What should we do to the state? So we have the state on that second line, and we say, let's map this to new state. Again, immutable things are awesome. So what we do here is we say, we know nothing about follow state. State, we know nothing about. It's just some arbitrary state. So copy over that follow state. We have no business changing it. We know nothing about it, so just copy it over. So we say state.v.followState, and we're done. But now the number of friends, we know something about that, and so we want to put that new information into the new state. And so at that point we say, okay, put the new number of friends in the number of friends spot, and now we have our state. We kept the old value for the follow type, we kept the new value for new friends, and now we're done. For what it's worth, all of those other observables will mutate only the follow type and not the number of friends, because none of the rest of those actually have anything to do with the number of friends. So you're always only changing one part of your state at a time. So now let's look at the view model. The view model has a view state. So you can see in the view state, we've defined everything that you could possibly need to render this button, everything. So if you know these 6 fields, you can make any of those buttons. Just set these values correctly and it will render whatever you want. This is all of the fields that we need. And in the view model, we say, we have the state of this button. Now, how can I map that to the view state? How can I map that to the color and to the text size and to the font and to all of these things that we want? And so, again, looking here, it's the state to the view state. They're observables again. This is a simple mapping function. Looking into the view state, I've already covered this, but again, it is just a data class that describes everything we need to render this view. And you can make the argument, do we need to have something separate to do this mapping? And I wouldn't ask the question if it wasn't murky, so shrugs. You don't necessarily, but I would make this argument, having worked with it, that it makes the code so much simpler that it's worth its weight in gold. You'll see this code later, but it comes down to a single line, and it's really hard to mess up, so for that alone, I think it's worthwhile. All right, diving in. What does one of these look like? Well, you have a view state, and you're really just saying, what string should show for this button? What's the color? Should it be hollow? Should it have an indicator? It's true and false. It's strings. It's colors. It's really only that. It's really hard to mess up because it's only that. So that was all it was doing. It was taking the type of button and it was telling you how you should render it. And the last component, the button component, this is what's actually doing the rendering. So you can see there's a component with a driver and a model. And inside of here, we have the onView state. And this is what we're doing. We're saying, hey, has your color changed? Okay, tell the view to update its color. Hey, has the string changed? All right, let's set the new string on this text field. That's it. Again, it's really hard to mess this up because all you're doing is saying, have you changed? Check yourself. All right, so just wrapping this all up, we have view intentions. It defined all the things that could change this view. We had a model which took these intentions and decided how to mutate the state. We had a view model which said, all right, here's the state of the button. What sort of properties do you need to have? And then we had a component which actually set those properties on the view. Now, plugging this into an app, this is something that you would do. You would say, here are your intentions, make a component from those intentions, and then call start on it. So these couple of lines of code can be placed anywhere in your app, and it will maintain itself in that you will never need to touch it again. It will call it all its own observables and deal with all the state changes. So I'm going to rush through this because we don't have much more time. What did we find? It wouldn't compile. This sounds bad, but it's actually great because when it did compile, it worked on the first try, which needless to say did not happen before. So types are great. It's modular and composable. It's easy to test, like really easy to test, guys. I'm not kidding about this. It's so easy to test. It's easy to maintain because it's easy to test and to update to a new spec. But the bad part of this is that if you don't have people on your team who think like this, you need to ramp them up, and ain't nobody got time to ramp everybody up on the team. So what happens is that there are 2 people at my company who currently know how to do this, and they do all the maintenance on these components. Animations are an outstanding issue that I'd love to talk to other people about because it's not clear how to handle them. And there's boilerplate code. You've seen 4 files for each of those. Now, the surprising thing is you may look at this paradigm and say, there's no way that this could work without a perf hit. It works without a perf hit. We really could not find one. We tried, and we couldn't find a case where this was measurable enough to affect the end user. So the conclusion, this has made me feel like doing this on a daily basis at work, jumping up on a couch and saying, my life is awesome. I cannot recommend it enough. I can't tell you how much easier it's made my life as a developer. And so I'd highly recommend looking at these technologies. Maybe the way that we do it at my company isn't working for you, but there's so much to be learned from the web, and right now we're leaving it all on the table. So I'd highly recommend everybody look at these technologies and see if there's a way that they can help them. And if you have ideas, I'd love to talk about it. You can find me here. Thanks.